My name is Lindsay Jensen, and I'm going to be explaining how to find a probability corresponding to the variable x in a binomial distribution using one of three methods. This method involves calculations involving the binomial probability formula, which is also the basis for the other two methods. So I have already written out the binomial probability formula, and I have also written what each of the variables means. So n is the number of trials, so basically it's the number of either questions you're going to answer on a test or the numbers of times you're going to go show a horse, for example. X is the number of successes, so how many times you completed or a show, or you answered a test answer correctly. P is the probability of success in any of the trials, so let's say you have multiple choice questions. So the probability of getting it correctly, if you just randomly choose one, is 25%. And then P is the failure, or Q is the failure, sorry. So it would be the opposite of 0.25, or 1 minus P, which would be 0.75. So here is our question. An exam has 20 multiple choice questions. A student takes the exam and answers each question randomly. What is the probability that the student will get 5 questions right? So the first thing I'm going to do is I'm going to rewrite my original equation, which is P of x equals n exclamation point divided by, in parentheses, n minus x with an exclamation point times x exclamation point times P with to the power of x times Q, sorry guys, to the power of n minus x. So that's my original equation written out again. So next thing I'm going to do is I'm going to determine what my n equals, what my x equals, what my P equals, and what my Q equals, so that it's easier for me to put them into my formula. So my n is going to be 20, because that's how many questions we're answering. My x is going to be 5, because that's the number of trials or number of things we're looking at. My success, so P is going to be my success rate, which will be 0.25 because it's multiple choice questions. And my Q is going to be my failures, which is P, which is 0.25, because you're going to subtract that from 1, which is going to be 0.75. So now I'm just going to plug the numbers in. Sorry, guys. Alright, now that I have my numbers all plugged in, I'm going to use basic algebra to solve my problem. So the first thing I'm going to do is I'm going to do my parentheses. So I'm going to do the 20 minus 5 with the exclamation point. So I'm going to do the parentheses, 20 minus 5, And then on the TI-84 plus calculators, or the 80, it doesn't have to be a plus. So your exclamation points are going to be in math, all the way over to probability, and it's going to be down to number 4. Alright, and then I was going to hit enter. So that is part of the bottom of my equation. So next I'm going to multiply, because I just did this number, right? So I'm going to multiply this number by this number. So times 5, math, all the way over the probability, down to the exclamation point. Alright, and I'm going to hit enter. So that is the number that I'm going to be dividing by. So next I'm going to take the 20 exclamation point and divide it by the number that I just got up here. So 20, math, all the way over the probability, down to 4, enter. And then on these calculators you can do a fancy thing where you can go hit the divided by button, go up to the problem you did before and highlight it, and hit enter, and it's going to transfer the numbers for you, and then all you have to do is hit enter again and you get your number. So I know it's kind of the cheater way, but these numbers are going to be really, really big to write out because it's 1.5692 to the 4th, and it's just kind of a crazy number. So I'm going to rewrite this piece of the question so I don't get lost in my equation. Okay, so now I'm going to multiply by the 0.25 to the 5th power, and that equals 9.765 to the negative 4th. So that I'm going to write out. So alright, so then actually I need to round, so this is going to be 977. So then I'm going to do another multiplication with the 0.75, and because it's 20 minus 5, it's 15, so 0.75 to the 15th power, which is going to be 0.01336. And then I'm just going to go through and I'm going to multiply these together using that same technique as before. So I'm going to do the 15,504 multiplied by, I just deleted that, sorry guys. Multiplied by that number, right? Because that's the one we did. Okay. And then it's going to be multiplied by this number. And then I'm just going to hit enter. And this is my probability. So P of 5 equals 0.202. So if I multiply that by 100, that means that I have basically a 20% chance of getting 5 questions right on a 20 question multiple choice test, which isn't great. But it's something if you don't know the answers. So that is how we use the binomial probability formula to solve this problem. See you later, guys.